Hello everyone, welcome to the vector calculus lesson. In today's lesson, we will talk about divergence of a vector. In the previous lesson, we had talked about gradient, and today we will see what is divergence of a vector and how it is calculated. We will also see some examples. So, divergence of a vector is represented by div dot f, or it can also be represented as del f, where f is a vector quantity. So let us consider if f is a vector quantity that is represented by xi plus yj plus zk, then the divergence of f, which is div dot f, it's also written as del f, so it's a dot product in between. So this will be del upon del xi plus del upon del yj plus del upon del zk. This is the del operator. We have already talked about this differential operator in the previous lesson, and this is applied on f. So here f is xi plus yj plus zk. This could be anything, but here we have considered that f is equal to xi plus yj plus zk. So this is the definition of the divergence of the function. We can also write it as del f upon del xi plus del f upon del yj plus del f upon del zk. Right, so this is pretty much similar to the gradient, with the difference is that the gradient is operated on a scalar, that was a scalar grad phi. You can watch my previous lecture to understand what is grad phi, and here the divergence is operated on a vector field. So this is divergence of f. Now let us understand a little bit more about the divergence, some points about the divergence. So divergence of f, this is operated on a vector field, right? So this is operated on a vector field, but it results in a scalar value, very much opposite to the gradient, where grad phi, the grad was operated on a scalar value and results in a vector value. On the other hand, the divergence of f, divergence is basically operated on a vector value and results in a scalar value. Now let's understand what is the divergence. Actually, it is the measure of outward or inward flow from a point. This flow could be of anything. It could be electric signals, it could be any fluid, it could be anything else. It could be any magnetic field, it could be anything else, electronic charge, anything. So it's basically the measure of outward or inward flow from a point. So if you can see, this is a point, and from this point we can see that there is outward flow. So some, let's say the electronic signals, it's coming out from this specific point. So the quantity or the measure or the magnitude of electronic signals that are coming out from this point will be called as the divergence at this specific point. So this is the net outward flow, and the net outward flow is always represented by a plus quantity. Here we can see in this chart. So this is the magnitude. Let's say plus 5 is representing the outward flow from this specific point. So whenever we have the outward flow, it is always called as a source. Oppositely, the sink, where we have inward flow, that's something going inside from that particular point. So the net inward flow will be represented by the divergence of the vector at that specific point. So it is again represented by a scalar quantity. You can see it's minus of 5. So it is representing the magnitude, and the negative sign that indicates that this is an inward flow. Something is going inside from that specific point. So this is the divergence. Now let us see some examples based on the divergence. So we will see this example number 1. Find the divergence of the given vector f, which is x square y square I plus 2xyj. So it's a two-dimensional vector. So we will use a two-dimensional system, and here the divergence of f will be, so we'll use del f, where del operator will be used for the two-dimensional system. So this is del upon del xi plus del upon del yj dot operator, and this is x square y square I plus 2xyj. So now we have to perform the dot operation. In the dot operation, we all know that I dot I is equal to j dot j is equal to k dot k. So basically this is k dot k. This is k dot k. It's always equal to 1. This is all equal to 1. And anything else, let's say I dot j or j dot k or k dot I, this is all 0. So when we multiply this, so this term will be multiplied with this term and will give I dot I will give you a 1. So and this once this term del by del x will be multiplied with this one, I dot j will be a 0. So we do not need to write this. So let us multiply all this together to have the answer. So this is, we'll multiply this with this first. So this is del upon del x square y square I dot I plus. Now I'll multiply this quantity with the second one. So this will be del upon del x multiplied with 2xy then I dot j plus. Now I'll multiply this term with the first one. So this will be del upon del y j dot producted by x square y square, and this is I. Okay, this is I plus last one. So this thing will be the last term. This is del upon del y multiplied with 2xy, and here we have j dot j. So now we'll use the results. So we can see that this I dot I will be 1. So this is del upon del x of x square y square plus this I dot j will be a 0. So this term will be a 0 plus again this j dot I will be 0. So this term will also be a 0 plus, and this one j dot j will be a 1. So this is del upon del y dot 2xy. Now we need to perform partial differentiation. We need to differentiate this with respect to x partially, which will be 2xy square plus, and we need to differentiate this partially with respect to y. So this will be 2x. So here we have got the answer. The divergence of f, or we can say del of f, divergence of f, this comes to be 2xy square plus 2x. This is our answer. Let us see one more example, which is for the three-dimensional system. Here we have this three-dimensional system. Find the divergence of u at a specific point. Here the point is also being given. The values of x, y, and z are given, and the vector function given as u. So we have to write divergence of u, which is del u. So now this will be equal to, now we will be using three-dimensional system, del by del x of I plus del upon del y j plus del upon del z k. This has to be producted with x to the power 4I plus y to the power 4j plus z to the power 4k. Now we'll perform a dot product. I'll not write all these statements because we know that I dot I only will be here, and j dot j will remain here, and k dot k will remain here. That will be 1, and the rest other all products will be 0. So I'll only be using this one. So this is del upon del x, x to the power 4 I dot I. I'll be using this. Then I'll be using del upon del y with y to the power 4 j dot j, and lastly this one with the last one. So plus del upon del z, z to the power 4 k dot k. And as we all know, in the dot product, I dot I is 1, j dot j is 1, and k dot k is also 1. So this remains del upon del x, x to the power 4 plus del upon del y, y to the power 4 plus del upon del z, z to the power 4. Now we'll perform the partial differentiation. In the first one, this is partially derivation with respect to x, so this will be 4x cubed plus we have to differentiate partially with respect to y, this is 4y cubed, and here we have to partially differentiate with respect to z, so this will be 4z cubed. So this is the divergence, but we have been given a point, so you can see in the question that this is the point where x is 1, y is -1 and z is 2. So we will replace x with 1 here. So this is 4 multiplied by 1 cube plus y with -1 here plus z with 2 here. So this is coming 4 minus 4 and 32. So we can cancel out and the answer is 32. You can see that this is a scalar quantity that gives us the magnitude. So here it's the answer plus 32. Let us see one more example. This is the last example for the today's lesson. So you can see if u is equal to x square plus y square plus z square, this is a scalar function. So here u is a scalar function, and v is equal to xi plus yj plus zk. This is a vector function. Then we have to prove that divergence of u dot r is equal to 5u. Okay, pretty simple. So let's do it. We'll start with the divergence of u dot r. So this will be, we can see that this is a three-dimensional system. So we'll be using del for the three-dimensional system. So this is del u dot r, which is equal to del upon del xi plus del upon del yj plus del upon del zk. So this is the del, and then u dot r. So what is u? U is x square plus y square plus z square, and then what is r, or here we can say this is v. Okay, right? So this is xi plus yj plus zk. Okay, so let me write it del upon del xi plus del upon del yj plus del upon del zk, and then I would like to multiply this with this. This is a scalar and this is a vector. So the product will be x cube plus xy plus xy square. This is plus xz square. This is I plus. Okay, I need to use big. Then this is yx square plus y cube plus yz square, and this is j. And the third term will be, this will be zx square plus zy square plus z cube, and this is k. Okay, right. So now we need to perform the product of these two. So as we can say, the ith term will be multiplied with ith term only, and jth term will be multiplied with jth term only, and kth term will be multiplied with kth term only, and all these will give I dot I will be 1, j dot j will be 1, and k dot k will be 1. So this will result in del upon del x, x cube plus xy square plus xz square, and as we all know, I dot I is 1, plus next one will be del upon del y, and this will be yx square plus y cube plus yz square, and as we know, j dot j is again 1, and the last term, this is del upon del z, and this will be zx square plus zy square plus z cube, right? And now we need to perform the partial derivation of all these three terms. The first term will be partially derivated with respect to x. So this will be 3x square plus y square plus z square, plus this has to be partially derivative with respect to y. So this will be x square plus 3y square plus z square, right? And the last term partially differentiable with respect to z. So this will be x square plus y square plus 3z square, right? Now we need to add all these together. As we can say, 3x square, 4x square, and this will be 5x square. So here we have 5x square, then y square, 3y square, and y square. So this will again be 5y square, and the last one z square, and 3z square. This will also be 5z square. So we can take 5 as common. This is x square plus y square plus z square. And you can see in the question that this is equal to u. X square plus y square plus z square is equal to u. So we will replace this by u. So this is equal to 5u. And you can see we have proved this. The divergence of u dot r is equal to 5u. So we have got our answer, and we can say that we have proved this. So thanks a lot for the day today, and we will be discussing the curl in the upcoming lesson. Thank you so much.